So to recap what we did so far this unit, we did areas, we did arc length, which is the distance that you go along a curve, which super geeks me out. That's so cool. You can find that distance. What we're going to do today are volumes using cross sections. You don't have to guess whether these are dx or dy. It's going to say perpendicular to the x-axis or the y-axis. So if it says x-axis, that is a dx problem. You are going to do upper graph minus lower graph. If it is sideways, it's going to say y-axis. Like they're going to come right out and say it in the problem. You do not have to guess. Remember how with the areas, it was like, I don't have a better explanation than we'll just look at it. It's going to say on the paper, you have a big clue this time. Perpendicular to y-axis is going to be dy, and you're going to do right minus left. Put your R and your L on there. Do you have an imagination? No. You're going to have a little bit of an imagination with this, and you're going to have to imagine the shapes popping up out of the paper at you. I don't have a piece of paper that will pop shapes up out of the paper at you, okay? But this is what this would look like. You would have this circular base, and that's all you're going to see on your paper would be something like a circle. And we're going to say that there are triangles popping up out of the paper at you. How many triangles? An infinite number of triangles, okay? And it creates this three-dimensional shape that we're going to find the volume of. This is literally how 3D printers work. Do you know how they print a slice at a time? Okay, these are all your slices. This is one that has a circular base and the shapes are rectangles. Do you see that? You're going to have to imagine. Every time I bring up imagination, I think, did you ever see Inside Out? Yeah. Do you remember like Imagination Land and Cloud Town? I would die for Riley. Do you remember that? That's where my brain goes. You're going to have to use your imagination. Find that part of your brain and use your imagination because I don't have a paper that will pop shapes up at you, okay?
How did you do that?
Well, you get that this is a two-dimensional piece of paper, right? Okay. Oh, this printed badly. I just realized that right now. I am so sorry. The words are over here on the... Oh, well. We're going to have to persevere. So the base of a solid is bounded by these. What is this going to look like? Because we have to graph that to start with. What kind of curve? A quadratic, which is a... We got there. Parabola. It's going to be... flipped upside down, concave down, and moved up 1. Okay, cool. So we're going to start at 0, 1. We got there. Didn't take that long. If we plug in 1, this will be 1/4. 1 minus a fourth, 3/4. About there. Good enough. We're just trying to get a visual. If we plug in 2, 2 squared is 4. 4 over 4, 1. And 1 minus 1 is 0. So this is your upside down parabola. And then it also says the x-axis and the y-axis. So look, you have two choices. You can either take this section right here or this section right here. Which one should we pick if we're being smart about it, though? The positive one. If you ever get a choice, pick the positive version of whatever it is. All right? Now you're going to have to find two pieces of information. What is your shape? And perpendicular to the x or the y-axis. So first of all, what is our shape? You just have to read. Squares, okay? So off to the side, we're going to draw a square. Sorry, my hand hits the projector whenever I get too close. We're going to draw a square, and perpendicular to... That means it's a dx problem. Everything is right side up. We're good to go. So here's what you have to imagine. Turn on your imagination. You have to imagine an infinite number of squares perpendicular to the x-axis popping up out of the paper towards you like this. Do you see what I'm saying? Okay. It's like a loaf of bread, but there's an infinite number of slices, which would be really cool. Although they'd be very, very thin. Okay. So we are going to write the base of our shape as upper minus lower. What is the upper graph or the upper equation? Yeah, that 1 minus x squared over 4 minus the lower graph, which is what? 0, right? It's the axis. So you can write minus 0 if you want, but you don't need to. All right, it was just that equation. Now, what's that? Yeah, it's upper minus lower, but the lower graph just is the axis, so it's 0. So I'm not going to write minus 0. Now you have to take what you know about squares. If that's the base, what's the height? That, right? I'm writing it because I'm doing the problem in front of everyone and trying to explain it. If you don't want to write it again, you really don't have to, if you understand how a square works. All right, now we're ready to set up our integral. We want x values for our boundaries. So it would be from where to where? 0 to 2. Leave a gap. You want dx. And inside of the integral is the area of your shape. So how do you get the area of a square? It's that squared. So 1 minus x squared over 4 squared. Oh, I will let you have Desmos open for this lesson. I'm going to pause while everyone gets Desmos open. Well, for example, I mean, a square or a rectangle is just going to be one side times the other side. I mean, that's just dimensionally what it is. If you take a rectangle and cut it in half, like if you imagine this room as a rectangle and you go from corner to corner, a triangle is half of a rectangle, so it's 1/2 base times height. I don't have better explanations than they just are what they are. It's kind of like who decided 1 + 1 was 2? Nobody. I mean, it just is. Nobody like came up with it. They probably just messed around with the dimensions until they figured it out. All right, I didn't even do it yet. Hold on a second. We had a bunch of side conversations, which is totally fine, but I just need to... Okay, did anyone else get, or I got, what did you get? 1.066? Okay, well, I wanted to make sure. Yes, so in delta math, it would be 1.067. So actually, let's practice doing that. 1.067. We'll practice rounding instead of truncating. On the AP exam, they'll take either answer. All right, let's try this one. Base of a solid is the region bounded by one arch of y equals sine of x. If you could pretty please for me, go ahead and change the like labels here to pi over 2 and pi. I just didn't end up changing them, but we want to count by pi since it's a trig function. Go ahead. They don't usually give units to these types of problems, but and you guys can have your computers open because we're going to use Desmos, but you shouldn't be using it for anything else, okay? For example, say it was inches. A volume would be what? Inches cubed. An area would be inches squared, but they typically don't put them for this. So you just don't make them up. You just put nothing. All right, where does sine start? 0. And then we're going to have a wave. So it's going to look like this. One arch. So if you get a choice of which one you're going to pick, again, you should pick what? It's the positive one. Choose this little hill of the graph. So then you need to read and find 2 pieces of information. What is your shape? And then perpendicular to which axis? So it says equilateral triangles. What does that mean? All 3 sides are the same. Okay, so draw yourself an equilateral triangle. And it says perpendicular to the x-axis. So we're going to do upper graph minus lower graph for the base of our shape. What is the upper graph? Sine. Let's try this again. What's the lower graph? 0. So it's sine of x minus 0. I'm just going to write sine of x. Now we're ready to set up our integral. What are your boundaries going to be? 0 to pi. Good job. Leave a gap. It'll be dx. And inside of there, you're going to put the area of your shape. A triangle is 1/2 base times height. Once again, I am a very big proponent of set it up blank. Set it up blank, right? 1/2 base times height. What is the base of our triangle? 6. Now, I have some bad news. We're going to have to do a little bit of work to get the height. No. It's a little bit of algebra and a little bit of geometry, and I promise you'll be okay. No. Okay. I'm going to shorten the reins on you guys a little bit. I love that there are so many other conversations. You guys need to be quiet and listen to me now. Do you understand? This is too much is going on in this. It's taken way longer than it should. Be quiet and listen to me and write down what I'm writing down. Okay. So we're going to do the Pythagorean theorem. Try to just look at half of this. Now, if it's an equilateral triangle and this side is sine of x, that means this side is also sine of x. Okay, that's the hypotenuse. And how much would just this part be? 1/2 sine of x. I don't have space to write that in there, so you're going to have to just, hold that in your mind. So we're going to do a squared plus b squared equals c squared, Pythagorean theorem. So we're going to have h squared plus 1/2 sine x squared, that was this little part, equals the hypotenuse squared. And we're going to have like a couple steps there. I'm going to write little because I sort of ran out of it. All right. So h squared plus, now if you square a half, that will give you 1/4. If you square sine squared, we put the squared in the middle because you're squaring sine, not x, equals, and then this side would just be sine squared x. We're still trying to get h by itself, so now what would you need to do? Yeah, subtract. Now this is 1 sine squared minus 1/4 sine squared, which would be 3/4 sine squared. And then your last step to get h by itself, square root. Now we're going to square root everything individually. The square root of 3 is the square root of 3, okay? Square root of 4 is 2. And the square root of sine squared is just sine. Does square root of 3 over 2 ring any bells to anybody? Oh my gosh, it's like it's on the unit circle. Wonder why that is. Okay, so I'd like for you to put this in your calculator. We'll make sure we get the same thing. If you aren't in radians, it's going to give you the wrong answer.
What did you get?
I got this.
All right, 0.680. That still won't round up. So 0.680. Are you in radians?
Oh, it's because you did the whole fraction. Oh, it's just for 3.
Okay, and we're back. So let's go ahead and flip to the next one. I have like one of each kind of shape you might come across on here. I'm trying to do like one of each thing. All right, the base of a region is bounded by, all right, what is this going to look like? Yeah, cubic, like a wiggly thing, moved up 1. All right, so we're going to go up 1. If you plug in 1, you're going to get 2. If you plug in -1, you're going to get 0. It looks like a line. You just need to know that it isn't. It's going to do something like that. Y equals 0 would just be like the x-axis. And then x equals 1 is right here. So it looks like part of a Hershey Kiss or something. Ooh.
Whoa.
So you need 2 pieces of information you need to read. What is your shape and perpendicular to what? Ooh, this one's going to be the y-axis. And what's our shape? A rectangle. Draw yourself a rectangle. Immediately, when you see its y-axis and you know it's a dy problem, you have to go and rearrange your equation. Instead of y equals, this needs to be x equals. Okay, so we have 2 steps there. What would you do first? Yeah, subtract 1 and then cube root. And again, I don't know why this works, but just circle that. Whenever we go to use that, that's the part that we want to use. So the base of our shape is going to be right minus left, sideways this time. So what is our right graph? This one I'm kind of high. Just 1. Do you see how that's just literally 1? Okay. So 1 minus, what is our left graph, the curvy part of this Hershey Kiss? Yeah, this thing that we circled here, right? Cube root y minus 1. So it was right minus left, exactly like what you did with the areas. Now, what is the height of these rectangles, popping up out of the paper at us? You have to read to find that as well. 2 times that. Yes, it's 2 times whatever this width is. So it's 2 times this stuff. Okay, so we're ready to set up the integral. It needs to be y values for the boundaries. So look at your y-axis. It'll be from where to where? 0 to 2. Leave a gap, put dy. Inside of there, you're going to put the area of your shape. So how do you get the area of a rectangle? Is that better? Yeah, it's base times height. Now, so that we don't have to write this all out twice, it would be 2 times this stuff squared. Good. Okay, so we're going to have 2 times all of that stuff squared so that you don't have to write it twice. Yes. Y values for your boundaries. So from here to here. So everybody go ahead and try and type that. Do you know how to type a cube root? CBRT, or you can open the keyboard and find it there. So there's 2 different ways to do that. Yeah, or if you don't like that, you can open the keyboard and it's in there somewhere. I think it's under functions, and I think CBRT is a lot easier if you don't want to memorize that. I got 6.4. What did you get? Perfect. Was that enough wait time for the calculation? The old button pushed? Okay. All right. This is going to be a review of geometry. Or let me just throw it out there. Does anyone know what this is going to look like? Is a circle. Perfect. Do you see how it's just x and just y? It's not like x plus 2 or x minus 7 or anything. It didn't get shifted. The center is still going to be the origin. The radius is the square root of whatever number it equals. So the radius is going to be 2. Okay, so the center is 0. You're going to go 2 in each direction and draw yourself a circle. It's not really going to probably look like a circle. It's going to look like a squashed tomato. You know what I mean? It's hard to draw a circle, so just do your best. It's hard to draw like a really nice, perfectly circular thing. All right, we need to find what shape we've got and perpendicular to what. That's a lot to unpackage. What does isosceles mean? 2 sides are the same, and then right means a right angle. So it's actually a 45, 45, 90 triangle. Do you get what I'm saying? 2 sides are the same. It says the hypotenuse is the base. So when you draw it, the hypotenuse needs to be the side that's on the bottom. So this would be the right angle, and then those are the 2 legs of the right triangle. So it would look like that. The hypotenuse is the base of it. I know, right? Yeah, calculus will make you remember everything you've ever learned in every other math class. All right, and then perpendicular to x-axis. Now, we need to take this equation and make it be y equals. So we have a little bit of work there. What would we do first to try and get y by itself? Yep, subtract x squared, so 4 minus x squared. And then, now when we did a cube root, it didn't matter. But when you do a square root, you get... Correct. You get plus and minus. Okay, so watch me point to this. This semicircle is the positive square root And then this one that's below sea level is the negative square root. When you get the positive and the negative, the plus minus, when you square root, this part is the positive, this part is the negative. That seemed like everybody, that didn't mess anybody up. We're all still okay? Okay. So when you go to do the base of your shape, you're going to do upper minus lower. So it's going to be this minus that, okay? So, and I think some of you are already mentally doing it, but let me get everybody there, okay? So you're going to have square root of 4 minus x squared minus negative square root of 4 minus x squared. And what's going to happen to the negatives that some of you are realizing already? Positive. And so if you have that plus that, you have 2 of that. If you have one of something and then another of something, you now have two of them. Huh. No way. All right, now we're ready to set up our integral. And as a heads up, we're going to do this one by hand because it's not going to be that bad. Trust me. We'll see. Boundaries are going to be from where to where? All right, -2 to 2. Leave a gap, and you're going to put dx. And then inside of there is the area of your shape. So a triangle is 1/2 base times height. Our base is, yeah, this, right? Like that stuff. Hold on, let me get you there. Now, I'm not going to need to do the Pythagorean theorem because you have these similar, do you remember similar triangles? I always call it the mommy triangle and the baby triangle when I teach it, all right? But if this is 2 square root of stuff, I know that this is 1 square root of stuff. Do you see how it's just half of it? Okay, so it is just this. You had 2 of them, so halfway, like these are congruent as well. Now, here's why we can do this one by hand. A lot of stuff is going to cancel. There's, a good bit that's going to go away. What's going to go away here? Yeah, the 1/2 and the 2 cancel. And then if you have a root of something times a root of something, you just get that something, yes. Our brain doesn't really read the whole thing. You just say that stuff, like when you say it to yourself. So we can do that antiderivative. Antiderivative of just plain 4. It's 4x minus 1/3 x cubed, such that -2 to 2, and then we're going to do upper minus lower and leave it alone. So if you plug in 2, that's going to give you 8 minus 2 cubed is 8, so 8/3. Oops. And if you plug in -2, it's going to be practically the same thing. It'll be -8. And then the negative will cancel, so plus 8/3. I believe in my heart you could go further and combine like terms and get a common denominator. I'm not worried about that right now, though, so we're just going to end there. But if it was multiple choice, you'd have to keep going. That is not going to be an answer choice. All right. Yeah, there's going to be a 16/3 in there somewhere. I'm fine with it, though. I think you guys could do that if I'd made you. All right, base of a solid is region bounded by 1 minus x squared. What's that going to look like? Parabola that is upside down and moved up 1. Good. Okay, so up 1, you've got an upside down parabola. So something like this. The other one, x to the 4th. X to the 4th or x to the 6th or x to the 8th, as long as nothing else weird happened, is going to also be a parabola, but just like skinnier, like stretched out, okay? So this is going to, they aren't technically, the vocabulary word is not technically parabola, but it's what it's going to look like. It's going to be facing upwards, and this one moved down 1. So you're going to go to -1, and this one's going to be stretched out a little bit, but it'll still be facing upwards. So this is the area of the base of the shape. You have to imagine whatever we have popping up out of the paper at us. So what is our shape for this one? All right, semicircles, which is just a half circle, perpendicular to the x-axis. So the base of your semicircle is upper graph minus lower graph. Okay, which one is the upper one? the 1 minus x squared minus the lower one, which is that x to the 4th minus 1. Again, if you distributed the negative in your head, cool. I'm just doing the problem in front of a whole group of people, so I didn't want to skip a step. We're going to distribute the negative, and then what else could we do to like condense that a little bit? Yeah, 1 plus 1 is 2. Then you're ready to set up the integral. What are your boundaries over here? Yep, -1 to 1. And inside of there, you put the area of your shape, your cross section. So what is the area of a semicircle? 1/2 pi r squared. Set it up blank, put dx at the end. I will be honest with you, this always goes super well until this step. And on the AP exam, one of the wrong choices will be if you do this, because it is such a common mistake and they're evil. All right. People will take this and just put it in there. That's not the radius. That is the diameter. The radius is half of that. So you have to do this. Okay. And then we're going to all have fun typing that in. But yeah, if you forget that half and you do the diameter instead of the radius, that will be one of the wrong answers. I 100% guarantee it. And then you'll think you did it right because it'll be one of the choices that's there. Oh, this is not working. Are you typing it as well? I'm not the only one typing this, yes? Or you did it already? Okay, I'm just checking. I just want to make sure I'm not the only one.
Oh, yeah, I realized.
Instead of 1/2 pi, I just wrote pi over 2. I got 1.93. If it was delta math, you would have to do 1.935. I would prefer 4. I like to truncate, but delta math will mark it wrong if you do that. 1.935.